Okay, so the next way that we use inequalities is when we're talking about different types of numbers and the number line. And again, this is something that you might have been briefly introduced to in first year, but we're going to do it a little bit more formally now. So there are three main types of numbers. There's actually four, but we don't do them on the number line. So I'll mention it, but we won't use it on the number line. So the first type of numbers are the most commonly used numbers, and they're represented by the letter N, capital N, with an extra line through it like this. When we're back in the classroom, I'll explain why it's written like this. And this N stands for the natural numbers. Now, the natural numbers are also called the counting numbers because we use them to count. And it's a good way of thinking about them because when you start counting, you don't start counting at 0, you start counting at 1. And you don't count in halves and 0.1s and things like that. So the natural numbers are the set of numbers that start at 1 and they go up in whole numbers and they go on forever. So the natural numbers are the whole positive numbers. Now 0 is not negative, but it's not positive either. So whole positive numbers only. We can see the set there. We're used to drawing a number line for these. So a number line for the natural numbers starts at 1 and goes on forever in the positive direction. So it looks like this. It starts at 1 and then it goes on forever in the positive direction. So we've seen a number line like this before. To illustrate that we don't include the decimals between the numbers, we do a little ball, a little dot on each of the numbers like this to show that that's what we're including and that we're not including the decimal numbers in between. And to illustrate that we're going on forever in this direction, we colour in the arrow as well. So let's do an inequality on the natural numbers. So if we want to have an example here, we might say, represent the following inequality on the number line. On a number line. And it looks like this. X greater than or equal to 5, and X is a natural number. Remember this symbol from sets? It means an element of. So I'm saying that I want to make a list of those numbers that are whole and positive and bigger than 5. So if I draw my number line, I actually don't even need to include all of the numbers smaller than 5. I can start anywhere that I want to, but I will start at 1 just to show it this time. 1, 2, 3, 4, 5, 6, 7, 8. I don't need to go as far as this. I'll actually just make it a bit smaller. So you wouldn't keep going, drawing lots of numbers to illustrate this. So I look at this and I say, what's the smallest value that X could have? Could it be 5? Well, I've got my little equal sign under here, so it could be 5. And I draw a little dot on top of 5 like this. And then, do I go this way? No, because X is bigger than 5. In fact, this is like an arrow pointing my direction, pointing this way. So 5, 6, 7, 8, and I'm going to keep going forever in this direction. 9, 10, and so on. There's an infinite number of numbers. So that's how I represent that on the number line. That's the natural numbers on the number line. Let's take a look at the next set of numbers. Well, we're also interested in whole numbers that could be negative, and these are called the integers. So they're represented by the letter Z, and they're called the integers. And again, you have seen that word before, but you mightn't remember. So the integers are whole numbers only, no decimals, no fractions. Whole numbers both positive and negative. So 0 is included here as well. And if we show the set of them, it goes on forever in both directions. So like -2, -1, 0, 1, 2, 3, 4, 5, 6. So it goes on forever in both directions. If I want to represent the integers on the number line, I need to draw a number line that looks like our x-axis in coordinate geometry. So it has arrows on both ends like this. You don't even have to put 0 in the middle, but we will do here. So 0, 1, 2, 3, -1, -2, -3, and of course we have it going on forever in both directions. Now, again, we want to indicate that we don't include the decimal values in between the numbers. So we just do little balls, little dots on top of the numbers, and we colour in the arrow to say it can go on forever in that direction, and little dots on these whole numbers, and we colour in this arrow as well to show that it can go on forever in that direction. Let's do an example of an inequality with this. We can be asked to represent the inequality x less than 2, and x is this time, so you can see the type of number is shown with the information. X is an element of z, x is an element of the integers on a number line. So on the number line, this is what this looks like. I have my number line going on forever in both directions. And I know that I have to include 2. So sometimes people ask me, how do you know how many numbers to include on this? I'll always go 1 or 2 numbers above and 1 or 2 numbers below the number that I'm given in the inequality. So I'll start up here and I'll have 4, 3, 2, 1, 0, -1, -2, however much I have space for. And then I must put in the dots that are represented here. So 4 is not smaller than 2. 3 isn't smaller than 2. 2, this is a strict inequality, 2 is not smaller than 2, it's equal to it. So the first number that I can include is 1. And I'm going in this direction. Remember, this is like an arrow pointing my direction. So I do include 0, I do include -1, -2, and I indicate that I keep going forever in this direction as well. So that's what an inequality on the integers looks like. Now the third set of numbers that we want to learn about, is called Q. And Q is called the rational numbers. This is the set that we don't use. On the number line, okay? So we'll write down the definition of it, but we won't actually draw number lines for this. It's a little bit complicated to draw this on the number line. So the rational numbers are all numbers that can be written as a fraction of integers. What do I mean by that? It means that I have an integer, a whole number on the top, and a whole number on the bottom. So for example, 2/3 is a rational number because that's a fraction, but also -8 is a rational number because I can write it as a fraction. Just because I don't write it as a fraction doesn't mean it isn't one, because I can write it as -8 over 1, or -16 over 2, or anything like that, -24 over 3. All of those are the same as -8. So because I can write it as a fraction, it is a rational number. Now we don't do inequalities with these types of numbers. but I wanted to include it for completion. We don't do inequalities with Q. So the last type of numbers that we're going to learn today is the real numbers. And as you can guess from what we did previously, this includes the decimal numbers. And the real numbers, much bigger than any of the other sets of numbers, because there's an infinite number of them between any other two numbers that we pick. So these are all numbers including decimals, whether they can be written as fractions or not. So there are some numbers, but we won't talk about it too much right now, that cannot be written as fractions. One example would be pi. Pi can't be written as a fraction. We can approximate it with a fraction, but we can't actually write it as a fraction. So all numbers, including decimals, whether they can be written as fractions or not. So for example, 1.2, 18, minus 57.13289, the square root of 2, pi, etc. All of those are real numbers. When we want to represent the real number on a number line, of course, so you'll notice I didn't do a list for this because I can't list them. There's an infinite number of them in between any two numbers, but I can represent it on the number line. 1, 2, minus 1, minus 2. You can put dots on the numbers, but I want to show that I'm including every single number in between any two numbers. So I colour in the whole of the number line, and I colour in the arrows going in both directions. Okay, I do want to do several more examples with the real numbers, but I'm going to stop here for today because it's a little bit more complicated than the previous two that we've done. So more examples on these guys tomorrow. But you have the 4 types of numbers, which is what I want you to familiarize yourselves with tonight, and the idea of the 4 symbols that we have in inequalities as well. Okay, thank you.